Good day, people. Welcome to One-on-One Private Maths Tutors. Today we are looking at the combined science paper in Zimsec. Now, these papers are similar to the syllabus in Cambridge, GCSE. So today we'll be looking at the combined science specimen paper. All right, we are going to look at the chemistry part. So, what do we have here? The nuclide notation of elements X and Y are given below. So, first we must understand what the nuclide notation means. All right. When we have the X is giving us the element symbol, the 11, this number here at the bottom, or the smaller number, is giving us the atomic number, or proton number. All right. And this 23 here, the bigger number, is giving us the mass number. Now, what do these numbers represent? This is the number of protons, as it is 11 is the number of protons in the element, in the nucleus of the element. And 23 is the mass number, which is protons plus neutrons. Right. That's the number of protons and neutrons in element X. So we are looking at element X, number of protons. Proton number is 11. So here we put 11. All right. So number of protons, 11, number of neutrons. So to get the number of neutrons, we say 23 minus 11. And what do we get? We get 12. So number of neutrons is 12. Okay, give the nuclide notation of a possible isotope. What is an isotope by definition? An atom, or we can say atoms of the same element. How are they identified? Atoms are identified by the proton number. If two atoms have the same proton number, it means they belong to the same element. Atoms of the same element with different number of neutrons. So the number of neutrons may be different, but if the number of protons is the same, that means it is the same element. Okay. So if it is copper, it should have the same number of protons, but different atoms can have different number of neutrons. So we can take this Y, it should have 17 protons. An isotope of this one can have 35, 36, 37. So let's just put 36 there. So the only difference between this and our isotope is the number of protons, which will increase the mass number or decrease it. But if the number of protons are the same, then it is the same element. The number of neutrons may differ, which means that this number can be different. All right, I hope it's making sense. That is an isotope. Write down the electronic configuration of element X. So, element X is 1123, which means if it's an atom, the number of protons should be equal to the number of electrons. Okay? Protons equal to electrons. Why do we say that? It has to be a neutral atom. Okay? So if we have 11 electrons, how are we going to do it? The first shell, so we have our X, the first shell will have 2 electrons. The second shell can occupy a maximum of 8. Okay, so there we have our electrons filling up the shells. So what do we have? We have 1, 2. Remember, this is the symbol, noted electron. So our electrons, for simplicity, let's put dots and not crosses. Okay, I think this will be a better representation. We don't want to mistake the symbol for electrons. So we have 1, 2 plus 8, which is 10. Now we are left with 1. The outer shell should now have 1 electron. So it's 2 for the first, 8 for the second shell, and then 1. So we should have 2, 8, 1. That is the electronic configuration. Electronic configuration means how are the electrons placed in the shells as we go from the inner shell going out. So this is the electronic configuration for our element X. Okay. Calculate the relative molecular mass of sulfuric acid. Now let's look at this formula. We have 2 hydrogens, H2, 1 sulfur, and 4 oxygen. What we need here is a periodic table. So when we go to the periodic table, we should look at the mass of each of these elements. All right. So let's go to our periodic table. Okay. So for our H, we know our hydrogen, the mass is the mass is 1. For our oxygen, the mass, which is this bigger number, is 16. For our sulfur, the bigger number is 32. So we'll go back. So 1, 1, 32, 16. So it is 2 times 1, because we have 2 hydrogens, plus 1 sulfur, 32, plus 4 oxygen, 4 times 16. This should give us okay, going on our calculator, we have 2 plus 32 plus 16 times 4, which would give us 98. So the mass of this molecule of sulfuric acid is 98. Okay, there are no units, it's just counting the number of protons and neutrons in the molecule of sulfuric acid. Okay, that is all for this question. So we encourage you to join us at one-on-one private maths tutors for revision and lessons that are done live on Zoom or through WhatsApp and Telegram, where we send you videos of each topic by topic, section by section, because we work according to the syllabus. We don't want to do more, we don't want to do less. We want to do strictly by the syllabus for only 250 Rand or $15 per month per subject. You can benefit from our expert team. All right. Thank you.